Okay, we are doing an example on testing a mean, and I wanted to walk through this entire procedure because something like this will be on the test. And now you've seen my rants in the lecture notes on my opinion of the p-value method. And what I have done in the test is I'm going to give you a question like this one or something similar, and I'm going to give you a list of things I want, like the null and alternative hypothesis, the test statistic, and I'm going to tell you give me a conclusion. You will not be required to give me a p-value. You will not be required to do the traditional method. You could do the p-value method, but you're going to have the option. So as you go through these problems, pick a method that works for you, and I recommend the traditional method, but you might decide that I'm crazy and you want to use the p-value method. And stick with it, because then that way you're not flipping back and forth between it. Either way should give you the correct answer at all times, so just simply pick a method and go with it. And while that might mean you might not always get every part of a homework problem, it will give you the right conclusions, and that's what matters, because on the test you're going to be asked for bits and parts. Like you might have a test question that asks you for the null and alternative hypotheses. You might have a question that asks you for the critical value. But when it comes to an entire problem where you're coming up to the conclusion, you are going to have the option of what you want to do. You won't be asked to give a specific p-value or specific critical value. So let's attack this problem, and I'm going to do it the traditional method, which is what I recommend, but obviously you could do the p-value method if you prefer. Now, first thing I've done is I've written all the basic information here. So we have been given 751 body temps. We've been given the sample mean and the sample standard deviation. Now, as soon as you see that you've been given the sample standard deviation, not the population standard deviation, you should click and go, okay, I need to use the t-test. So remember, on mean you have two options. You have the z-test or the t-test. The difference is the population or sample standard deviation. If you know the population standard deviation, you use the z. If you only know the sample standard deviation, you use the t. And obviously, real life, you're not going to know the population standard deviation. And in all our projects, if you decide to do the null hypothesis test and part 5, you will be using the t-test. And we have an alpha of 0.05. Now, our null hypothesis is always what we're testing. So in this case, 98.6. And then if we look at this question, the mean population is less than. So this is less than 98.6. This tells us our second fact, that this is a one-tailed test. Now what we do next is we want to find the test statistic. So we know it's a t-test. So if you go here to your formula sheet, you can see here known, that's the z, we don't need that, we need this one, the t-test. So we have x bar minus mu over s divided by the square root of n. So taking our numbers, that's 98 minus 98.6 all over 0.08 divided by the square root of 751. Now, so we're going to simply get out a calculator, 98 minus 98.6. Now divide, and use your parentheses here. Don't let arithmetic mistakes cloud you up. Square root and parentheses equals. So negative 20.55. This is our test statistic. Now we also need the critical values. So we can do this in Excel or we can do this in the t-table. We know, and did I turn on my pencil? Probably. We want 0.05, one tail. So we go down here and we look for our n. Our n is 751, so our df is 750. You can see that's right between these two. So that's between these two values. You can see the number between it is 1.647. Since we're less than, it's negative. And you can see I just picked the number between this because I'm halfway through. Honestly, these are close enough. You could use either one and you would be okay. That wouldn't be a huge deal. So negative 0.1647. Now, if you pulled up Excel, if you wanted to do this in Excel, close. Was obviously mad at me earlier. Formulas, more functions, statistical. And go down here to T inverse, put in 0.05, and this is one-tailed. it assumes one-tailed. If you were two-tailed, you'd have to factor into that. Our degrees of freedom is 750. And you can see I get the negative 1.647 that I had guessed. I find the table quicker and easier, but obviously that's up to you. So these are our comparisons. Now how do we compare them? Well, we draw a line and we draw our little chart. And I like our little chart here. And here is negative 20. Okay? And negative 1.64 is here. Now we are less than. That means we want something smaller than negative 20. Is negative 1.6 smaller? Okay, so this value, and I've got this all confused because that's why you shouldn't write and talk. Okay, so this is our critical value, 1.64, and so you want something smaller than this. Is negative 20 smaller than this? Yes, it is. So what you do is you draw your little thing, you put in your critical value, and if it is in the tail, so in this case, this tail here, you're going to reject. If you had two tail, you would have two tails to look at. In this case, we just have one, and you pretty much, is it past it? And it is. Negative 20 is definitely smaller than negative 1.64, and it falls in this tail area, so that means we can reject. And that means, by rejecting the null, that we can say that our alternative is true and that our mean is less than 98.6. So going back here, we can see we want to reject, okay? So we reject since the test statistic is less than the critical value. So that is our answer, and that's all there is to it. So what are the steps here? Let's go over the steps. Obviously, write down your information. Write your null and alternative hypothesis. Find the test statistic. So do your formula. Find the critical value. And then you simply compare. That's really all there is to it. Obviously, there are parts to this. You have to, do the number crunching here. You have to look this up on the table. But in essence, it's get the test statistic, get the critical value, compare them. It's really a three-step process. Now, obviously, each of these steps are not a simple, quick issue, but they are a simple linear progression. Find each, compare, you're done. Obviously, also make sure you know if you're doing a Z or T test. As I said, really look at that standard deviation. If you know the population, you're going to do the Z. If you don't, you're going to do the T. And that's really all there is to that part. So hopefully this helps you see how you work the traditional method and the different steps and tools you need to get your final answer.